We are privileged tonight to have Dr. Don Johnson with us. This is, I believe, your third time? Yes. And Dr. Johnson has 2 PhDs, one in computers and information science, and the other in chemistry. Makes him especially well qualified for the things he takes on, and so we are very privileged to have him again tonight. Please welcome Dr. Johnson.
Good evening. That was fun singing. Tonight we're going to be looking at the origin of mass and energy of the universe and its fine-tuning. We'll be approaching this from different aspects. One of the things we'll talk about the naturalistic scenarios that have been proposed and that are common for the origin of mass and energy. Including the oscillating universe and quantum fluctuations of vacuum energy creating basically the universe out of nothing. And we'll also talk about multiverse, multi-universes, and the collision of multi-universes to produce our universe. We'll also look at potentially the supernatural perspectives on the origin of universes. Or the universe, and the observed fine-tuning regardless of how the universe came into existence. So if we look at the origin of mass and energy, we know that from science that there's a very, very strong law of the conservation of mass and energy, which can be written mathematically as the change in energy plus the speed of light squared times the change in mass is equal to 0. Now, one of those is negative because that comes from E equals mc squared, where Einstein's theory of relativity says basically there is no net change in the total amount of mass and energy of the universe. Now, it used to be thought that the delta E and the delta M were both 0. That was so that, for example, back in the olden days, they would teach matter can neither be created nor destroyed, but can be converted from one form to another. Well, and also when you have energy, you can create energy from one form to another also, but it always says the same amount of energy, so delta E would be 0. Then Einstein came along with his E equals mc squared and kind of changed things a little bit. And that made it necessary to change the law of science so that those two things are now combined into one law, that the total amount of mass and energy is the same. We realize that mass can be converted into energy and vice versa. So, for example, if you shoot high energy beams at one another, you can create subatomic particles of mass from the energy. So that can be done. For this equation, for example, if you had a loss of 1 gram of mass, of nuclear mass, then you would have a 90,000 gigajoules of energy that would be created from that. For example, the Hiroshima bomb that destroyed the city of Hiroshima converted 6.4 milligrams of nuclear mass into energy in that explosion that wiped out the city of Hiroshima. If you had 1 ounce of material and could convert that into energy, you can't, but if you could, that would be equivalent to 4,400,000 of those bombs. If you had something the size of a bowling ball and you could convert that into energy, that would supply enough electrical power to meet the United States' energy needs for a year. So it doesn't take much mass to make an awful lot of energy. So science really has no explanation, however, for the origin of the mass and energy because the scientific law says it doesn't change. And so somehow it exists, but we don't really know how from science. Stephen Hawking, for example, said, I want to know why the universe exists. Why is there something greater than nothing? It's a good question. So we'll look at some of the naturalistic scenarios for the origin of mass and energy, because the naturalistic scenarios would say that either matter has always existed or else we have matter being formed out of nothing, one or the other. Notice that if it has always existed, you would have another scientific law being violated because energy is still being used for useful work, and therefore the second law of thermodynamics says that entropy, which always increases in the closed system like the universe, it means it couldn't possibly be infinitely old, because otherwise there would be no capability of doing any work. So that the universe's mass and energy, as far as science is concerned, has always, it's there. It just is. And we don't really know how it happened. But for entropy, Isaac Asimov said, for example, all changes are in the direction of increasing entropy, of increasing disorder. Entropy is just basically a measurement of disorder, of increasing randomness, of running down. Yet the universe was once in a position from which it could run down for trillions of years. How did it get into that position? Because the universe is basically a machine, and it's running down, supposedly. If it existed forever, it would be done, and there would be nothing, it would be dead energy-wise. The solution, one of the solutions is the oscillating universe, that the universe is continually in a big bang, big crunch scenario. It's oscillating. That repeatedly does that. Right now we're in the big bang phase where it's expanding. Eventually gravity will slow it down, and then it'll all form together and form a small, minuscule volume again, and then repeat the process. So it basically is an oscillating universe. There are some scientific problems with this scenario. One of them is that there is insufficient mass to overcome the escape velocity of the universe, because the universe is expanding at more than the escape velocity, and therefore it cannot, by gravity, come together again. One of the things that's been proposed for this and for some of the other scientific findings also is dark matter. Things that we can't see, but we know they must exist, and there's some of the, one of the proposals that can take several different forms is that somewhere between 68 and 80% of the universe, the mass of the universe, really is in what is called non-baryonic particles. Baryons are like neutrons and protons, and what is proposed is that there's other kinds of exotic material that we don't know about that comprise the majority of the mass of the universe. And so one of the things that would do is allow for the universe to contract again, so it could have been in existence forever. Some of the proposals call these things WIMPs, weakly interactive massive particles. Just last month, there was a study done in South Dakota in a very deep mine using a lux detector, a large underground xenon detector, which was set up to be able to detect these WIMPs, and it couldn't detect anything. So for a while it looked promising, but there's no evidence that they exist. Another one, in contrast to the WIMPs, is the macho scenario. The macho scenario has massive and compact halo objects that are actually ordinary matter but very dense, for something like a black hole, but not nearly as massive as a black hole would be. But they exist of ordinary matter, just in a very compact form. And those are scattered throughout the universe to make up the missing mass. So those are two things And there's no evidence for either of them at this point, really, but those are proposed hypotheses to make up the missing mass that, among other things, would allow for a contraction of the universe. Another problem with the oscillating universe is that not only is the universe expanding at greater than the escape velocity, but the rate of expansion is increasing, which is a very interesting phenomenon, that there's no explanation for that. And so what is driving this apparently anti-gravitational behavior on the part of the universe? Nobody claims to understand why it is happening or its implications. That's called dark energy. We can't see it, we don't know what's causing it, but something is causing the universe to expand at increasing rates, which shouldn't happen. Gravity should slow it down and eventually pull it back together, or in the case of the escape velocity, it should continually slow down but never reach zero. But something is there that's making the rate of expansion faster and faster. It also should be mentioned that entropy is not yet maximized, and randomness would be maximized after infinite time by the second law of thermodynamics. And since things are still happening in the universe, we know that it's not infinitely old. Another real promising looking or sounding scenario is the quantum fluctuations of a vacuum. There was nothing and then it exploded to form the universe by spontaneous methods. One of the authors, or actually several authors, have said there's really no such thing as nothing, since the general theory of relativity allows for empty space to have vacuum energy, which could spontaneously produce, without cause, via quantum tunneling, the mass and energy of the universe. And as it expands, the energy that's in the gravitational distance of this expanding mass and energy is apparently fairly close to the amount of mass and energy. And so people like Stephen Hawking and other people have said, well, it's really the creation for free, because the mass and energy of the universe that we can see and measure is compensated by the gravitational potential energy of the things that are being separated. Therefore, there's no big deal. Doesn't explain how it happened or anything else. But basically, what is proposed is that you had this quantum fluctuation, and by what's called symmetry breaking, it basically created two things: mass energy of the universe and gravity. And those were formed spontaneously, out of nothing. Okay? The problem with that, the major problem, is that to consider that the 3 times 10 to the 55th grams of mass of the universe was spontaneously generated from quantum fluctuation is kind of a stretch, to put it mildly, because not even an electron size equivalent has been ever detected or observed to happen that way. And the universe is some 10 to the 74th times larger than an electron. Therefore, to speculate that's how it happened is a stretch, to put it mildly. The most popular scenario nowadays is the multi-universes made up of various vibrating strings using string theory. String theory is something that says all matter and energy and everything else is made up of vibrating strings in anywhere from 10 to 14 dimensions. Now, we only work with 4 dimensions, 3 in space and then time, but that's all we have. And so these universes then, supposedly, you have these universes. By the way, the universe, if the universe is everything there is, multi-universes means there are multiple everything there is. Anyway, the collision between existing universes, then as they collide, they created a new universe, ours. And the 10 to 14 dimensions that these other universes had were reduced to the natural laws that we have in our universe and the 4 dimensions that we work with and that we see. That makes sense, right? So that basically you had collapses of things that were multidimensional into our 4-dimensional space. It has been estimated that more than 10 to the 500th universes would be needed in order for our universe to have the fine-tuning that it does if it just arose from collisions of other universes. That sounds pretty reasonable. That's a one with 500 zeros after it. Could be done, being as there are only about 10 to the 80th atoms in this entire universe, one with 80 zeros after it. But other people have indicated, string theory, for example, Lee Smolin says, no part of it has been proven, no one knows how to prove it, because strings are operating in dimensions that we can't observe scientifically. We can only observe things in our 4 dimensions, and that's it. And so we can speculate all we want about other dimensions, and there certainly could be other dimensions, but what they are and how do you measure them or whatever would be outside our realm of science. It has been said that without any explanation for nature's fine-tunings, we will be hard-pressed to answer the intelligent design critics, that will look at the fine-tuning of the universe, and what is acknowledged that unless we can speculate there's basically almost an infinite number of universes, we're kind of hard-pressed to answer the critics that believe there's an intelligent designer. So, some other problems with the infinite universes in the grand design. Stephen Hawking describes how miraculous it is that the laws of physics allow for a universe that is hospitable for life, in which the universe has an excess of matter over antimatter, and galaxies with stars and planets that last for billions of years. And he explains it all using M theory, basically multi-universe theory. But one of the critics of that in Nature says, besides the absence of any compelling experimental evidence for it, there's another difficulty. Its predictions are far from unique. There are 10 to the 500th different ways to curl up the extra 7 dimensions. So Hawking has an 11-dimension space, but there are 10 to the 500th ways that they could form something else. And so it's far from unique, in other words. So even if it were true, and how they curl up determines the fundamental constants and what we 4-dimensional creatures see as the laws of physics. But this is presented as science because it's outside of our realm of observation. One of the major reasons, of course, that this is proposed is because of the fine-tuning that we'll talk about in just a little bit. But you see, if there are almost an infinite number of universes, the theory goes, and I've seen it on television, for example, on PBS, that we just lucked out. Because if there are an infinite number of universes, one of them has to have the capabilities to have life. And we just lucked out in happening to be in that one. Okay? That's the scenario, and that's presented as science. But in any case, all of the ones covered so far, at least, have some kind of a big bang and expansion and so forth, whether you have an infinite expansion and then contraction, spontaneous formation out of quantum fluctuation, or from a colliding universe. Basically, all of them have a beginning of this instance of the universe. And it's called the Big Bang. Big Bang cosmology rests, however, on many untested and in many cases untestable assumptions. Indeed, Big Bang cosmology has become a bandwagon of thought that reflects faith as much as objective truth. So there really is no way of testing these things from science. And that's, maybe there will be someday, but at this point there is no scientific basis for it. So when people say this is science, well, it's really philosophy. Another possibility that was kind of implied in the previous one, that since the Big Bang rests on faith, and that is that there could be supernatural creation. Ooh, what a unique thought. That infinite energy beings would convert some of their energy into the mass and energy of this universe, or otherwise somehow create the mass and energy. But it basically involves something supernatural. But this scenario, like all of the other scenarios that we looked at, is really outside of known science. All of them are based on scientifically unknowable assumptions. All of them are philosophical or theological beliefs. They're not based on something that you can test, measure, scientifically examine. So it is no more scientific to believe in a natural scenario than it is to believe in a supernatural scenario, since science cannot account for the origin of the mass and energy of the universe. Each philosophical or theological belief involves assumptions that can't be verified or falsified and would not be bound by known science. None of them are bound by known science. Therefore, all of the scenarios fall outside of what we know about science. Now, if we look a little more deeply, from a biblical perspective, since the laws of science can't explain the origin of mass and energy, and we know that the conservation of mass and energy total is constant, then we need to look at, well, what happens then when we apply Einstein's E equals mc squared to the 6.4 milligrams of mass that was converted in the Hiroshima bomb? A single drop of water is equivalent to 10 of those bombs. One drop. So if you wanted to create a drop of water, you would have to supply the energy equivalent of 10 of those Hiroshima-sized bombs in order to create that one drop of water. Interesting. But the Bible says, by faith we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. Notice it doesn't say it was created out of nothing at all. It says it was created out of what was not visible. So when it says all things were created by him and for him, we can think about God and say, well, God is omnipotent. He can use his infinite power and do whatever he wants because he's also omniscient. He knows how to do it. We don't know how to do it, but he does. And so if you ever stop to think about, well, what does it mean when the Bible says the voice of the Lord is powerful? Well, when God said, let there be, and there was, what kind of power was released in that statement? Well, in Hiroshima-sized bombs equivalents, it's 520 million, trillion of those bombs in order to create the mass and energy of the universe. That's how much energy it would have taken to create the 3 times 10 to the 55th grams of the universe's mass. So if you ever wonder, what does it mean when it says the voice of the Lord is powerful? Well, there it is. When God said, let there be, and there was, a lot of energy was released. regardless of how the universe was formed, the mass and energy, we can empirically determine that the universe is very fine-tuned, that any changes in any number of different parameters would make it impossible for life to exist, or in many cases even for the universe itself, for planets or anything else to exist. The physical constants for the weak and strong nuclear forces, the electromagnetic and gravitational forces, the ratio of the forces and the electron-proton masses and other properties are all very critical and very unique. The Earth's orbit, tilt, rotation, magnetic field, atmosphere, and composition are all life critical and also very unique. And we'll talk a little bit more about that. Concerning the constants of physics, Stephen Hawking writes, "The remarkable fact is that the value of these numbers seem to have been very finely adjusted to make possible the development of life." Very finely adjusted. That's called the fine-tuning or the anthropic principle. Anthropic is toward man, so that basically for the life. An accuracy of 1 part in 10 to the 10 to the 123rd is the precision needed to start the universe on its course, so says atheist Roger Penrose. Can you envision how big of a number that is? 10 to the 123rd is a 1 with 123 zeros after it. 10 to the 10 to the 123 is a 1 with 10 to the 123 zeros after it. I work with big numbers all the time. I can't even imagine how large that number is. But it is really fine-tuned. There is, for me, powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming, so says Paul Davies. Yeah, I think that's probably a common sense thing. A common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics, so says atheist Fred Hoyle. So some super intellect must have monkeyed with the physics in order to make these things behave the way they do. On the other hand, the Bible says, "He who fashioned and made the earth, he founded it. He did not create it to be empty, but formed it to be inhabited." So it should be basically not a big surprise to see that the earth looks like it was fine-tuned, because it was. Some more fine-tuning quotes that are kind of interesting. If we nudge one of these constants just a few percent in one direction, stars burn out within 1 million years of their formation, and there's no time for evolution. If we nudge it a few percent in the other direction, no elements heavier than helium would form, no carbon, no life, not even any chemistry, no complexity at all. Another one, the really amazing thing is not that life on Earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge. And it would be total chaos if any of the natural constants were off even slightly. Even if you dismiss man as a chance happening, the fact remains that the universe seems to be unreasonably suited for the existence of life. Almost contrived. You might say a put-up job. Could be. Another interesting observation by one of the people who believe in 10 to the 500th plus universes out there, that basically to explain things that appear to be finely tuned really are not. And his stance is that if we're just one of 10 to the 500th universes, then it's not really unlikely that one of them happens to have the properties that we see in our universe. So that doesn't mean that our universe is fine-tuned. What it means is that we just lucked out to be in the only universe that we could observe it. Okay? Anyway, the Earth is extremely unique. Astrophysicist Hugh Ross has compiled a list of probabilities to analyze what is the probability that any planet anywhere in the universe would possess the qualities that would be needed to sustain simple bacterial life for as long as 90 days. Okay? And so he looked through 650 plus astrophysical papers and calculated the probability of 501 parameters that he deems are necessary existing in any single one planet in the entire universe anywhere would be 1 part in 10 to the 311th power. So is the Earth unique? Yeah, because the probability of any other planet anywhere in the universe that would sustain even the simplest life would be 1 part in 10 to the 311th power. And long-term life or intelligent life or anything like that would be a whole lot less probable than that even. So Nobel laureate Steven Weinberg reflects on how surprising it is that the laws of nature and the initial conditions of the universe should allow for the existence of beings who could observe it. Life as we know it would be impossible if any one of several physical quantities had slightly different values. So life, the Earth, universe, is acknowledged by science as being very fine-tuned. Albert Einstein once remarked that the most incomprehensible thing about the universe is that it was comprehensible. Why should it be comprehensible if it was just produced by random fluctuations of something? But we can comprehend it. So one of the interesting comments from Robert Jastrow, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak, and as he pulls himself over the final rock, he's greeted by a band of theologians who have been sitting there for centuries. The idea that, we can look at the recapitulation then of the science part of this here, that there is no scientific explanation for mass and energy from science. We can determine that there is fine-tuning of the universe. It's empirically detectable. And the Earth is extremely unique in the universe. Okay, so those are some things that we can talk about from science, without any regard to anyone's religion, without any regard to the Bible or anything else, but those are definitely true. Now, what science tries to pretend is that these are all illusions. Many scientists, and these are just some representatives of them, that have written several popular books, the God Delusion by Richard Dawkins, for example, God, small g, God is Not Great by Christopher Hitchens, God, the Failed Hypothesis by physicist Victor Stenger, and Sam Harris writes a letter to the Christian nation that basically seeks to destroy people's beliefs in anything supernatural. And they do this under the guise of being scientists. That's what disturbs me. I mean, anybody is free to write whatever they want. But we are at war with people who are trying to say God is not only not necessary, but he doesn't exist. And there are many different things that are being done here in this war, and people are trying to use their science as to lend credence to what they say, to their philosophical and theological beliefs. So we are definitely, for example, on the Psychology Today website, very interesting, classifies creationism as a mental illness because it's a myth, and those who believe in this myth to be true are in a state of denial, among other things. So it's a mental illness to believe in creation. And this is being, promulgated throughout all kinds of things. Well, we have to realize that we are in a battle for our minds and the minds of our kids. For our struggle is not against flesh and blood, but against the rulers, against the authorities and the powers of this dark world, and against the spiritual forces of evil in the heavenly realms. And we need to realize that. This is not simply, this man against this man. We're battling, this is a spiritual battle. And the school systems are trying to get to influence our kids and grandkids to disbelieve in God. And that's their goal. And we need to realize that also. But we can realize also that the battle is the Lord's, and ultimately he's going to win. But one of my favorite examples is Nehemiah. In Nehemiah, he stationed people, and that the important thing here is that those who carried materials did their work with one hand and held a weapon in the other. What do we do in this country? We drop our hands, turn our kids over to the education system and say, teach them whatever you want. We do not equip them for battle. And we just, most Christians are scientifically illiterate. And it's not because they're dumb, because they're very smart. But we have not done the training and equipping to fight the battle. We've dropped our arms and let the enemy take over the televisions and the education systems. And we need to, if we want to have any impact, we need to do something about that. Contrary to what modern science says, the most significant scientific discoveries were made by Bible-believing Christians. Isaac Newton, for example, is regarded by scientists to be the greatest scientist who ever lived. And he spent more time studying the Bible than he did on his scientific endeavors. Johann Kepler, the father of astronomy, said several places, I was merely thinking God's thoughts after him. So it wasn't, God was the creator. He knows what these laws are. I was just thinking the thoughts that God made everything with. These people and hundreds of others acknowledge that he gives wisdom to the wise and knowledge to the discerning. For the Lord gives wisdom, and from his mouth come knowledge and understanding. And there have been hundreds of Bible-believing scientists who made science what it is today. Or not what it is today, but what it was when it was really good. But anyway, so it's just important to realize that, people, contrary to what the atheistic people would say, you don't have to check your brain when you enter a church. Science was founded and formed by God, by God's command. So it should not be something foreign to us. And it isn't for this group, but I encourage you to take that message to other people as well. One of the things that often bothered me is the fact that we can see galaxies that are billions of light years away. How does that fit with the Bible? Ooh. There are many different scenarios. One of the traditional literal 6-day explanation of creation and looking at starlight that's billions of years away, that took billions of years for the light to get here. When God said, let there be lights to light up the sky and so forth, that many people believe that God created a mature universe, and basically just like it is today. And if he could make the stars, there's no big deal that he could make the light as well. So that's not a problem. And perhaps he did it that way. I don't know. But in the Hebrew, reading right to left, in beginning had God created the heavens and the earth. There's a little bit of a leeway there for other interpretations. And a lot of people say, well, I don't really believe in a literal 6-day creation. They use day, age, and things like that. And because the Lord has, with 1,000 years is like a day and so forth. And they use that to justify the earth was really created over many centuries. That really isn't absolutely necessary, and I'm not going to, scientifically I can't prove this part here, but it's consistent with known science. Relativity, Einstein's theory of relativity, has shown, and it's measurably shown, that time does slow down with increasing velocity and increasing gravity. Those are known facts. Scientifically, they're verifiable. Okay? So if you enter a black hole, for example, time would stop because the gravity would be so high. People in their space travels have had their watches slow down. They're behind time when they land back on Earth because they traveled at a fairly high velocity. If you could approach the speed of light, time would stop. Okay? These are things that are known and they're calculable. But if, when God said, let there be, and there was a Big Bang equivalent, think about the implications of that. You would have all the mass of the universe would be in a very small volume. The gravitational pull at that point would be immense. It would be expanding at an extremely high velocity. Both of those things make time go slower. Okay? I'm not saying this is how it happened. I'm just saying that the general theory or the theory of relativity does allow for a little bit of rethinking of some of these things. For example, several authors have used the Einstein's general theory of relativity and have calculated that if this is what happened, the first 24 hours of time, actual 24 hours in the formless void that was to become the earth, as it was expanding out, 24 hours of time on that mass, if you were sitting outside the universe and looking in, you would have seen something that would have taken 8 billion years. Now, that's an interesting concept to me, because when we think of time, we think everything is always the same. Well, this is a reality that because of the slowing down of time due to mass and gravity rather and velocity, if that's what happened, the first 24 hours of time on that mass, which was to become the earth, would have looked like 8 billion years. Now the decrease is exponential, so that the day 2 of the next 24-hour period of time would only be 4 billion years rather than 8. And then the next would be 2, and so forth down. And so day 6 would appear to be 250 million years. And so if this is what happened, the first 6 days would have actually appeared to be 15.75 billion years. So is it possible for the Earth to have been created in 6 24-hour periods of time and allow us to see stars that are billions of years old? And the answer from science is yes, it's possible. I'm not saying that's how it happened, but I'm saying it's possible from science. Okay, does that make sense? Gerald Schroeder, in his book Science of God, calculates things a little differently. He uses the space-time expansion in a trillion-fold expansion of space-time, and from that, he calculates that 24-hour period of time of 6 days would be the equivalent of 16.43 billion years, which is pretty much the same as you can calculate from Einstein's theory of relativity. Again, I don't know if that's how God did it. I wasn't there. I was a little young at that point. But the main caution that make sure that we don't base our understanding on partial understandings and try to promote that as some kind of dogma, because otherwise we can get in a lot of trouble. Don't make my belief a criterion for salvation or something like that, because I've heard people say if you don't believe in a literal 6-day creation story like I believe, then you might as well throw out the whole Bible, and I wouldn't say that. We need to realize that our beliefs are based on our understanding and what God reveals to us, but also realize that science may be wrong in a lot of areas, and things that are taught as science today are definitely wrong in a lot of areas. So keep that in mind. There are some things that would point to a lot younger Earth and universe than what are portrayed as being scientific truth, however. And I think we should be aware of those. For example, the high oil and gas pressure. If everything is as old as what science says it is, there should be basically no pressure left. And so the high oil and gas pressure actually indicates that the oil and gas was formed less than 10,000 years ago. The magnetic field decay indicates less than 10,000 years. There were many reversals, I believe, during the flood. There's evidence that the magnetic field has reversed many times, and science would say, well, that happens on a fairly regular basis, and so we can't really go by that. But there are several other things like helium, for example. There's helium, which is a radioactive decay product that has been formed in rocks. And that indicates that those rocks were formed less than 8,000 years ago, otherwise the helium would have diffused out of the rocks. But since it's still in it, that puts an upper limit on the amount of time. Comet tails. Every time a comet revolves around the sun, it loses some of its mass, but we can still see comet tails. So they haven't been around for nearly as long as what supposedly the universe has been. The moon is receding by about 4 centimeters per year, which indicates that if the Earth is as old as what people say it is, the moon would have been right on the Earth, back a few millennia ago. That indicates really that the Earth, the moon has to be less than 1 billion years by far. The rotation of the Earth is slowing down by about 2 milliseconds per century. And if you go back a few thousand centuries, the Earth would have been rotating awfully fast back then. There are some radio halos that have been found in granite, for example, that indicates the granite was formed almost instantaneously, because the halos are formed by radioactive decay, and you can see the halo in the granite, which means that that granite had to have been basically instantly formed, because otherwise you wouldn't be able to see it. Another aspect is spiral galaxies. I don't know if you've ever seen spiral galaxies. Why are the arms still distinguishable? If they're as old as what people say there are, they should be all curled up, and you shouldn't be able to detect a spiral anymore. And a lot of people have said, well, that's one of the functions of dark matter, is to keep the spiral arms where they are. But I don't know if they've ever seen the laws of conservation of momentum or not, but even if you had mass there, the mass should be slowing down the further out you go. There have been unfossilized dinosaur bones with DNA and blood cells in them. If they're as old as what people say they are, that shouldn't happen. And people have been amazed that they found such things. Another very interesting characteristic, that mutations, there are an average of 60 harmful mutations in every newborn human being. 60. Now, that's not all that many when you consider there are, 6 billion bases along the DNA strand. So 60 out of 6 billion isn't all that many. But they accumulate. And so therefore, the fitness declines by about 1 to 2% per generation, which should yield extinction of our race in less than 10,000 years. Now, these things are known scientific facts that have been found by people who study them. And most people try to cover them up because they point to something a lot younger than what science would like us to believe. And so my point is, not that what I'm saying tonight is going to prove the six-day creation story or anything like that, nor that the earth was created 6,000 years ago. I can't prove that scientifically, but I can prove from science that it's a lot younger than what people have said it is. And so there might be some things that need to be thought through a little more, especially for people who believe in the Bible and Christians and so forth. So basically then, if we look at this, there really is no explanation for the origin of mass and energy of the universe. The fine-tuned nature of the universe is empirically detectable, and the earth is extremely unique within the universe. We also can realize that the Bible is consistent with known scientific facts. We don't know all the facts because our knowledge is only partial, but what we do know is the Bible is reliable and can be trusted. All scripture is God-breathed and is useful for teaching and correction and so forth. That the Christian faith is not a blind or anti-logic faith, because we can know the truth, and the truth will set us free. Our knowledge on any subject is limited because we only see a mere reflection in a mirror. But the proven reliability of what the Bible says will increase our confidence in its other predictions. Not that science proves the Bible or anything, I'm not saying that, but the predictions that haven't been yet fulfilled, the prediction of heaven and hell and judgment and salvation and so forth, those you can't prove because they haven't all taken place yet. And so the fact that there is good agreement on a lot of things can increase our confidence that it has a good chance of being right in other areas too. But we do need to realize that the world is blind to many of the truths that are in scriptures. because they've exchanged the truth of God for a lie. And so, if we keep that in mind, we should be in pretty good shape. I will have the PDF of this presentation. It's not there yet, but hopefully within the next couple of days I'll get it up on my website. My Christian website is 4im.org, and that has links to a lot of different things. It has links to many presentations, the other 2 presentations I've done here, for example, and a whole bunch of other presentations as well. Video presentations are there. A link to the Programming of Life video, which, by the way, has had over 176,000 online views so far, which is pretty good for a 45-minute science documentary. There's some references for intelligent design, and then some biblically based references there. This also is this whole thing is also on the website 4IM. So if you're interested or whatever, you can get that. I do have some books out there, for at least the books that I bought. I don't really sell books, but if you want to, donate a couple dollars or something for them, that would be wonderful. If not, if you need them, take them anyway. But anyway, so do you break before the questions? So if you have any questions, we'll come back later.
Yeah.
Hopefully answer them.
Let's take about a 5-minute break, but first I'd like to read you a poem. This is kind of tongue-in-cheek. It's called A Gravitating Question. Our universe grows cold and vast while transmutating into light that dissipates her former mass upon the trackless void of night. Soft radiance of gravity waves glows outward from each dying mass and slows all passing through its haze, so even light must move less fast. 2 functions slant that radiant slope. The first is time-based mass decay, which sends out waves of waning stroke, so older, strong waves lead the way. Geometry, the other hand, by inverse square of radius, depletes the strength of spreading bands to seem close range, impervious. For farther out, speed hindrance thins, a massward gradient ensues, where neighboring matter drifts therein, vibrating atoms bend to move. As dipole mass halves oscillate, both slowed toward haze and sped away, shared center of mass accelerates, equal reaction, opposite way. Momentum spills from balanced stores, rest energy converts to speed, and objects plummet in accord. We call the process gravity. Yet since far out twixt galaxies, those rival gradients invert. Can it be else than gravity that drives the universe apart? That was just for fun.
Anti-gravity.
Yeah.
You mentioned in your talk that, I guess you were talking about the Big Bang model of the universe where when it's first expanding, the gravitational forces are very high and the velocity is very high. And this causes clocks at that point then to slow down so that 24 hours on Earth would be equivalent to 8 billion years.
If you were in the position of God, for example, sitting outside the universe, it would have looked like 8 billion years have passed when really only 24 hours on Earth passed. And those would be actual times, if that's what happened. Yeah.
Do you have a reference for that I can have?
I've seen it in, I think, 3 different places, and I just kind of summarized things here. I could see if I can find it and put it on my website if you want. But the one that I know about for sure is Gerald Schroeder's Science of God, where he uses a little bit different scenario where he uses the expansion of the space-time fabric.
I'm familiar with Gerald Schroeder.
Okay.
I was not aware of the other one.
Oh, okay. Yeah, the other ones have used the general theory of relativity to do the calculations.
I'd really like to see that.
Okay, I'll see if I can find it.
Okay, thank you.
Yeah.
Doesn't that presume that time is in fact passing to that outside observer? And if you were
Well,
the time wouldn't pass at all?
if I don't know what the gravitational. I mean, if you were stationed outside of the expanding ball, which is kind of an oxymoron, because if the universe is expanding, then the observer would be in it also. But if you could have been outside of it to see the expansion, that's what would have happened. But basically, what I was trying to indicate is that the outer edges of the universe as it expands would continue going out, and they would travel at increasingly faster, or time would go increasingly faster because they're out further.
So we're saying perhaps not outside the universe, but on the fringes.
And the fringes, perhaps, yeah. And again, I don't know. You can envision perhaps someone sitting outside of the universe, but that would be a hypothetical thing also. Good observation. Yeah.
I have a question about dark matter.
Uh-huh.
Is there any way to prove that, or is that just something they made up to be able to make their theories work better?
Mostly it's to make the theories work better, but there's a lot of stuff that we don't know about yet. It has been proposed for two major things. One of them is the mass that would cause the universe to contract again, so that it might make a infinite expansion contraction feasible. But the other thing that dark matter is often used for is, like, for example, the spiral galaxies. If there's really a disk of dark matter in there that basically makes things all rotate because of the gravitational pull. But in my mind, that really doesn't make any sense, because even if it were a disk of dark matter, it would still have to obey the laws of conservation of momentum, which means it would slow down, the further out you got. But anyway, so it doesn't answer some things, but some people like to think it does. I don't know. Yeah.
When you were talking about, this is a very elementary question, because I keep going over things like the Einsteinian theory, E equals mc squared, the equivalent of energy and mass is maintained in the universe. When you were going through your explanation there, you talked about converting, a point, whatever, minute gram of matter into the massive amount of energy. And it just occurred to me, what happens to that energy? How does that be?
Well, realize first of all that only applies to when you do convert mass into energy, which right now only can take place like in an atomic bomb. When you have the nuclear energy of a nuclear power plant, for example, or an atomic bomb or something, where you've changed the amount of mass within the nuclei of atoms, and that's what creates the energy. When you burn, for example, a log on a fireplace or something, you're not converting any mass into energy. All you're doing is you're converting the mass of the cellulose in the log into carbon dioxide, and water, and other byproducts of the products of combustion. But you haven't lost or gained any mass, And likewise, the energy that's stored in the orbitals of the electrons in the cellulose structures, carbon, oxygen, nitrogen, whatever, those are all converted into, among other things, heat and light. You haven't gained any or lost any energy. When you apply the brakes on your car, which was accelerated using the energy in the fossil fuels by burning them, and then applying the brakes, the potential energy of the moving car, the kinetic energy of the moving car is converted into heat in the brake pads. I mean, you haven't lost or gained any energy in any of those processes. It's only when you convert mass into energy, like in an atomic bomb, that's when those equations apply.
But, yeah, but I mean, my question is really if the universe has to maintain a constant state, then that energy would have to exist somewhere. I think.
Well, it does.
What you're saying is energy is a wave, but the wave runs out. Then
Well, it's there. I mean, you can't lose energy. It's always there. It may be getting, like for example, when a butterfly flaps its wings, the energy goes out throughout the universe. But the further you get, the less interaction there's going to be. But the same thing is true of any kind of energy. It doesn't just go away. It's still there. That's why people can say, for example, when we see light coming from a star that's billion light years away, the idea is that light has been traveling for a long time. It doesn't just disintegrate. It gets dispersed because light travels in all the directions, but it's still there. Yeah.
And the ocean waves, the energy in that when it hits the shoreline.
Yeah.
What happens to that energy?
It's undoubtedly converted into heat, among other things, because I don't know if it's measurable or not by normal means, but you don't lose the energy. But the energy, for example, of a tsunami, you can easily detect that. There's a lot of energy released when it comes crashing into the shore, and certainly the energy of a wave, for example, you can see how it moves sand and things. So there are some observational ways of determining that energy has been released. Yeah.
So, are there accepted methods by which nature converts mass into energy? Other than us exploding bombs?
Well, it happens naturally in some radioactive decay where the daughter products have a less nuclear mass than the parent. So yeah.
So does this mean the level of energy in the universe is increasing? Or do we have reverse processes where the energy is being converted back into mass?
I don't know that. I've not ever done a study to see if all of the nuclear decay products produce a decrease in mass. I have not studied that. Oh, I'm sorry about that. But if some of them do, then you would have an increase in energy and a decrease in mass. But it wouldn't be a large amount of mass in any case.
I'm just saying, if it's going one way, you would think it would go the other way somewhere else, through some other process. Otherwise, you have a constant increase in energy and a constant decrease in mass.
Yeah, but it's only the unstable nuclei that is a fairly small amount of mass, percentage-wise, of the mass of the universe anyway, that would be involved.
We're assuming that stars are not an example of converting mass to energy.
Well, it does. That's one of the main thoughts of being the hydrogen fusion, for example, of stars, that many people believe that's what causes the heat and light from the conversion of hydrogen nuclei to fuse them into helium nuclei, which has a lower mass, and therefore the energy is released. So most people believe that's what forms, or that's what creates the light and heat from stars, including our sun.
So does converting mass into energy mean that there has to be no more mass, that the mass has to completely convert into energy?
No.
Okay.
We don't know how to completely convert mass into energy anyway, because only a very small portion of the amount of mass, for example, of when you convert in a nuclear power plant, for example, the percentage of mass of the fuel that's converted into energy is really minuscule. It's far, far less than 1/100%.
So isn't digestion a form of that?
No.
No?
Digestion is just chemical conversions, and that doesn't create any change in mass. When the only thing that we know about that can lose mass is in a nuclear event, where the nucleus loses some of its mass when different nuclei form that have lower combined mass, and that's determined by the number of neutrons and protons in the nucleus. Yeah.
Everything that has temperature above the background radiation temperature of the universe has black body radiation.
That's true.
And so that radiation, as it leaves, has a mass equivalence.
Well, it depends on where the I don't know that it loses mass, though, to do that. It forms. Well, do you have a decrease in the weight of objects as they have the black body radiation?
Well, does E equal mc squared?
Yes, it does. Yes.
Then if E is leaving, then you must be losing mass.
Well, unless the E comes from something within the body that is not mass.
What do you say for a mirror that's emitting light?
What do I say about it?
No.
Oh.
It receives that energy from some other source and is merely reflecting it, as could be your black body. You received it from another source and now is emitting it.
Anything above absolute zero, has radiation. Yeah, and
You see, especially with something really hot. Something's white hot, and it's cooling off.
mhm.
Then, as it loses heat, it loses energy.
Yeah, that's true.
Being photons, and those
Yeah.
photons have a mass equivalence.
That's true. That's true.
It's losing mass.
But the mass, well, the energy, we're getting into the photon mass energy duality of light photons here. But you haven't, it's true that the mass and energy is constant of everything. It's also true that anything above absolute zero can emit energy, but it doesn't mean that you've converted mass into the energy. What it often, anything, because if you have something at absolute zero, you would have no energy being emitted from it because it has no energy to emit. I don't know if that makes sense or not. So theoretically, if you had a chunk of mass at absolute zero, it would emit no energy, and therefore the mass would not decrease. It's only when the mass is heated up above absolute zero that it can emit energy. And what it's doing is emitting the energy from the body itself.
It's emitting the energy from higher energy states.
Right. Higher energy states within the electron orbitals. Yeah.
Those higher energy states have essentially mass.
Well, they don't have mass, but they're equivalent to mass. Yeah. Yeah.
You know what we're leaving out of this is velocity. Because the energy is mass times velocity.
Yeah.
When it's speaking of velocity.
Well, it's pretty well accepted that electromagnetic energy travels at the speed of light regardless of the speed of the object that's emitting the velocity. But, that's perhaps could be debated, but yeah.
Okay, sticking on that subject of velocity,
Ooh.
I've been thinking about the speed of light slowing down. So,
That's possible.
okay, and I feel like time is speeding up. So I was thinking if this was over unit time, and actually that would be if it's over unit time is speeding up, then velocity of the speed of light would be slowing down, therefore it is really not a constant.
And there's some not verified evidence yet, but there's a lot of speculation that perhaps light is slowing down.
Chuck Missler talked about it in
Yeah.
ABC News came out, a lot of people are talking about
Yeah.
it.
And I don't really know, I haven't seen any definitive science that indicates the validity of it, but it certainly has been hypothesized, and in my estimation, it has a lot better evidence than string theory, for example, that, you can't, at least you can study the speed of light, or we can't look at things outside of our four-dimensional universe. Yeah.
I was going to mention Hawking's book, The Grand Design.
Grand design. Mm-hmm.
It never delivers on its title.
Well, that really isn't surprising to me, but it's just an amazing thing that this all you need is gravity and M theory, and then you got the universe. So, yeah.
I didn't understand the drop of water.
Oh, if you were going to create a drop of water from nothing other than energy, you would first of all have to know how to do it, which we don't. But secondly, you would have to supply enough energy to do the conversion, because it can't just come out of nothing. But so there's two problems. One is supplying enough energy, which would be the equivalent of 10 of the bombs that destroyed Hiroshima. But even bigger problem would be knowing how to do it, because we don't know how to do it. We can shoot high energy beams at one another, physicists can, and produce subatomic particles of mass. At the small level, that can be done and can be verified. But how to create chemicals, we don't know how to do that. Yeah.
I've seen this thing about structured water, and they're putting energy into the water, and you say it's sort of like a life force energy. It's using that Curlin video to look at tap water, and it shows on a YouTube video like the energy is like a little dot, but when they structure this water using vortex, vortices with in a structured device, that there's more energy is being put into it. So what kind of energy is that looking at?
Well, if it's real, it would be probably something within either the chemical or the physical structure of it that would be storing the energy, and then emitting it as it decays or whatever it's doing. I've heard of that. I've never looked into it though.
Yeah, there's a website you can go to where he makes that device, and actually you can see it on that, what's a gas discharge? I'm not sure what the D stood for, but it's a machine that they look at. It's like using the Curlin
Oh, okay.
technology. You see it?
I've never had any experience with that, so can't really comment on it.
What about the chi energy?
The which?
The chi and
Chi energy from the Chinese. Actually, there's some papers in science journals that have been written that discuss that kind of stuff, and some of the findings are actually quite amazing. And so I have no idea the source of some of those things. Yeah.
It is rather presumptuous of us to assume that the only things that are valid are the things we understand, and anything that's ancient in nature must be ridiculous, because how would they know?
Right.
And it's completely possible that they knew things way back then that we still haven't got a handle on, and they've been lost over time. This stuff may be real.
Yeah, for example, if you stop and think about it, the early people that are recorded in the Bible, they were not only created with perfectly formed brains and fully powerful, but they lived for over 900 years. Think of the knowledge they could accumulate in that time. If you stop and think about it, well, I don't know. Where did all this stuff come from, and what all did they know by the end of their life? Because it doesn't take too many generations of, extremely intelligent people to do all kinds of stuff. And we don't know. At least I don't.
what about the cold fusion energy?
Cold fusion? The studies I've seen on it is that it was a dream. So far as I know, I've never seen anything definitive that validates cold fusion. Does anyone know any different?
A couple experimenters that have done it. The guy in Italy. There's a website, PESN.com, that covers all these emerging technologies. If you put in cold fusion at that website, you will find some definite stuff. And I've seen devices that were radiating an amazing amount of heat that were using this technique. And occasionally the device melts down. So they haven't gotten to the point to where they can bring it to market.
Several years ago, we went to a conference in Long Beach. It was called the Natural Philosophy Alliance, I think, something like that. And one of the speakers had been headed the cold fusion program under the Navy for a number of years. And then finally, they stopped receiving funding for it, and so the group of guys that had worked together formed their own corporation to continue the work. And at the time he gave the talk, right at that time it was going to press finally for a publication, scientific journal. But they used all kinds of methods to measure the things to be, would be good indicators of cold fusion.
Mm-hmm.
And they were getting fusion products, they were getting tritium, various other things. And every evidence that, they were getting fusion. Not at breakover or break even.
So they were still applying more energy than they were getting out.
Well, no, they were getting more out than they were putting in.
Oh,
But
okay.
not a commercial.
Oh, okay. Okay.
Not high enough to be really useful yet. But apparently there's something there.
It could be. Yeah.
Yeah, you mentioned about accelerating, the rate of expansion of the universe is accelerating,
Mm-hmm.
and that requires a force to accelerate it. What is commonly in the scientific community, how do they explain that?
Dark matter, or dark energy rather. Dark energy. Because basically it's dark because we don't know what it is, but we know it's something that's there that's causing it to. It's a mystery, basically. They use the term dark whenever we don't know what it is.
Now I see gravity flipped over.
Yeah, I I have no explanation for it, but you do? Okay, okay.
Basically, if you have a universe that's expanding, let's take a simplified model where it's expanding at a constant rate. It would take a certain amount of time, say, to expand per day. Then to double, it would take twice as long. And to double again, 4 days, 8 days. And so what's happening is we're out here at the edge of the expanding universe, and everywhere we look, we're looking into the depths of times past when space itself was smaller. And so that first half of looking back time is half of the age of the universe. The next half is 1/4. The next half is 1/8. The next half is 1/16. And so our perceptions of time as the universe expands, literally the clock rates in our local reference frame are slowing down. Everything is expanding, including planet Earth, including every atom in it, every pendulum, every chemical process. And so because our clock rates are slowing down, as we look further back towards the depth of the center of times past, it appears to us as if it's accelerating because our local reference frame is slowing down. So the model I just described doesn't need some mysterious energy. It actually follows what you'd expect to happen, that the universe is winding down.
I'm going to have to read that paper because it sounds interesting, intriguing.
So is gravity increasing? You mentioned that earlier. Time is slowing down,
No,
gravity's increasing.
See, gravity, everybody talks about gravity as if it's a fundamental cause. It's an effect. And if you understand, again, in that paper it describes the model, is that as the universe is expanding, wherever there's a concentration of matter, a planet or a star, that presence of all that wave functions that construct those particles of matter that can comprise that object causes jitter motion down at the quantum scale. So it literally slows down the expansion in and around that object. And that jitter motion dissipates with distance from the object, inverse square law. And so there's this dent. Now, meanwhile, this is happening inside the context of this cosmic onion. And so as it expands, and you're on a slow portion of that dent penetrating those onion layers, and those onion layers provide resistance, and that resistance is the impedance of the vacuum of space. And it's literally regulating the rate at which time proceeds forward. And so if you're on the slow portion of that dent, depending upon how slow temporally that dent in space-time is, that instantaneously manifests as a force of gravity, the gravitational field. And so I just explained to you how gravity works step by step, the mechanics of it in terms of these quantum wave functions.
And it's being continuously refreshed because of motion.
These quantum onion layers represent kind of like you think of it as holographic film. That when God said, "Let there be light," that wavefront that was generated penetrates those onion layers. That wavefront represents now, always. But what is happening now, this very instant. And so as it penetrating those onion layers, it's those interactions are defining what's the gravitational force at this particular point in space. What's happening with this electron orbiting the nucleus. And so it can create kind of a holographic image on these onion layers, a trace of those wave functions that generate those particles through all of time. So every time quantum, 10 to the minus 44th of a second, is imaging the universe. And then at the end of time, and the books are open, and God shows you your life.
Is that on? Does he use that Planck time to show us our life?
Well, it could be that it could be a holographic video of your life.
People have said it when they've been to heaven, they've actually seen those videos back of their life. Well, can I add then the idea of the matter and the antimatter, because that's the new thing, that there's
Oh.
matter and antimatter being created at all times. So if we're forming substance and we're putting faith out there, which is the substance that things hope for, and then there's the idea of particles coming and going,
I love
that fits what you're saying.
Yeah, exactly. Yeah, yeah.
Well, and that's one of the things that,
Gravity's not just on mass.
oh,
Okay.
you know, mass, one of the proposed methods of forming mass is to basically have the quantum to split off matter and antimatter, that when they combine they would form energy. But anyway.
What you were saying is the higher valence shell, because energy had to be added in the first place for it to come above zero.
Right.
So then that was what he's emitting and doesn't have to have mass.
Right. It doesn't change the mass. Yeah. Yep. One.
Hey, is it wise to, is it wise for us to mess around
With what?
with antimatter?
Oh.
Most of us don't have the opportunity.
Yeah. I've never had the opportunity to do it. But there are some people that are trying to create artificial black holes and stuff like that, which I kind of have a little problem with. But
Doesn't that come under the heading of self-limiting?
yeah. Anyway, yeah, that what we don't know would fill books. Let's put it that way. So anyway.